express 5 sine x minus 3 cos x in the form of r sine x minus alpha. This is an auxiliary angle form. We have 5 sine x minus 3 cos x. And we need to express this in the auxiliary angle form, r sine x minus alpha. R is positive and alpha is in between 0 and pi over 2, meaning that alpha must be a first quadrant angle. We need to find the exact value of R, and alpha is to correct to 2 decimal places. We can expand sine of x minus alpha using the compound angle formula for sine. That will give us sine x cos alpha minus r sine alpha cos x. And now, equating the coefficient of sine x. On the left, equating the coefficient of the sine x, you see on the left we have a 5, on the right we have r cos alpha. So r cos alpha is 5, and that gives us equation number 1. And equating the coefficients of cos x now. Coefficient of cos x, we have negative r sine alpha equals negative 3. So we can just cancel off the negative, and r sine alpha is 3. That is equation number 2. Okay, what we could do now is to find the value of r. We can find the sum of squares of equation number 1 and 2. We have r squared cos square alpha plus r squared sine square alpha. That will give us r squared, because cos square plus sine square is 1 from the fundamental identities of trigonometry. We have r squared equals 5 squared plus 3 squared, which is 25 plus 9, and that is 34. And r is positive, that is the positive square root of 34. To find the value of alpha, we can divide equation number 2 by equation number 1. We have sine alpha divided by cos alpha. That is tangent alpha, and that is given by 3 over 5. Tangent is positive in quadrant 1 and 3, but we are given that alpha must be in quadrant 1. Then alpha is given by inverse tangent of 3 over 5. We can find this value using the radian mode in the calculator, which is 0.54 to 2 decimal places. Then we say that 5 sine x minus 3 cos x, this is square root of 34 sine x minus 0.54. Part B, hence, so we must use the result in part A, state the greatest and least possible values of the square of all that. You look at 5 sine x minus 3 cos x. This can be written in auxiliary angle form. Let's look at the first part here. Sine of x minus 0.54. We know that sine has a minimum value of -1 and a maximum value of 1. So sine of x minus 0.54 is in between -1 and 1. We have square root of 34 multiplied throughout by square root of 34. Negative square root of 34 is less than or equals to square root of 34. Sine of x minus 0.54. This is less than or equals to square root of 34. But this is actually 5 sine x minus 3 cos x. So 5 sine x minus 3 cos x has a minimum value of negative square root of 34 and a maximum of square root of 34. There is a square here. So we can square this inequality for these negative values. Upon squaring, the negative value becomes positive. Then this must have a minimum of 0 because the square of any number must be non-negative, must be greater than or equals to 0. So squaring will result in a minimum value of 0. And when we square root of 34, that will give us a 34. That is the maximum value, and 0 is the minimum value.